Hi guys, welcome back to the channel. So today we are going to be solving today's late code question, which is subarray product less than k. So we are given an array of nums and then we are also given integer k, and then we need to return the number of continuous subarrays where the product of all the elements in the subarray is less than k. So suppose let's take this particular example where we have nums equal to 10, 5 and then 2 and then 6 and then k equal to 100. We need to find the number of continuous subarray such that the product of all the elements will be less than k. So suppose if you want to find via brute force, then we are going to take I, which is the starting point of the subarray, and then we are also going to consider j, which will be the end point, and then one more thing we should consider is one more thing we'll be considering is we'll find the product from I to j. So this will be our approach for the brute force, where we'll be picking one starting point, and then we are going to pick the ending point, and then from those endpoints we are going to calculate the product from I to j, and then we'll be checking whether this particular subarray's product is less than k. If it is less than k, then we are going to increment the answer, and then at last we are going to return the answer. So if we come to the time and space complexity, the time complexity is going to be big O of n cube. Why? Because we are taking 3 for loops in this particular case. Suppose let us try to optimize this particular solution where we have 3 loops. So we'll be using only 2 loops. Suppose let us take this particular example where we'll be taking I, and then we'll be taking j. This will be our j, and then now we want the product from I to j. That means we need product from I till j. So we'll try to calculate the elements from this particular end, and then we'll try to calculate till j, and then we'll check whether if it is less than k, and then we are going to increment the answer. So now we need to optimize this particular solution. So suppose let's take the prefix product where we'll be having the prefix of particular index, which is going to be some x. Then this is going to have all the product from start till index x. So we'll be having all the products ranging from the starting of the array, and then we are going to till the end index, which is x. Now if we want the product from I to j, then we are going to consider the prefix of j by prefix prefix of I minus 1. So this is going to be our answer. Like, we'll be having the product till j, and then we will be dividing the product from starting to the till I minus 1, so that we'll get the product from I to j. So for this it is going to take the time complexity of big O of n square, because we are taking only 2 for loops, and then we'll be building the prefix, which will be using the one for loop. Like, we'll be doing the product from starting, and then we'll be reaching till the end of the array. And then now let us try to optimize this particular solution. And one more thing is, here we are given constraints which lies between nums lies between 1 to 1000. That means it will not be having any negative integers, it will not be having any zeros. So we should not worry about any division or multiplication. Why? Because we'll not be having the division where we have 0 as our denominator, so we don't need to worry about that. And then if we want to try to optimize it better, then we are going to consider one more case, that will be our sliding window. Suppose let us take this particular example where we have 10, 10, 5 and then 6. So for this we need to count the number of subarrays which are less than 100. So let us try to take the first element, which is going to be 10. So now my i'll try to I'll try to uh, get the product product by multiplying with nums of this particular array element. If we try to do this at every step, so if I'll initialize product to 1, and then when I multiply with 10, then the product is going to be 10. Now I'll try to move the pointer to here, and then now we need to multiply it with 5, so then it becomes 50, and then I am going to multiply it with 2, then it becomes 100, and then it should be always less than the k. So at this particular point, suppose if I want the number of elements which are present in this particular array which ends at this particular index. Suppose if I take this particular product where I'll have at the starting point it will be 10, right? So I'll try to calculate the number of subarrays which will end at this particular point, which is at the 10. Then it is going to be only one answer. Why? Because the number of subarrays we can build using only this particular element as our end is going to be 1. That is going to be our right minus left plus 1. So the right and then left is going to be my pointers. So let us write those as well, so that we can understand better. So we will be having right here, right, and then we are going to have left. So now the starting point right will be here, and then left will be here, and then product will be 10, and then our answer is going to be 1. Why? Because we'll end at this particular point. Now at this particular point I am going to move the right to here, and then now I'll multiply whatever the number is present in this particular with the product. Now the product is going to be my 50. So as it is less than k, then we can consider all the subarrays which will end at this particular point. So it is going to be 1, which is this particular subarray, and then one more is we are going to consider this particular subarray, which is 10 and then 5. So that is one more thing. Now we'll try to move again. Right pointer to here, and then now at this particular point the product is going to be 100. Now 100 is equal to k, which is not feasible for our solution. That's why we are going to move the left to here, and then we are going to divide the whatever the product which is present by 10. So which is going to be again it is going to give us the result as our 10. So the now the product is going to be 10, and then as it is less than a k, then we are going to consider this particular subarrays we can build from left to right. Now there are going to be two subarrays, which is only 2, and then 5 and then 2. So these are going to be my two subarrays which I can build. So the answer is going to be for this, it is going to be 1 which is for this, and then 2 for this, and then again 2 for this particular index, and then now I am going to move the right pointer to here, and then we are going to multiply it with 6. Then it is going to be, my answer is going to be 60. Now it is less than k, so we will be considering all the elements, all the subarrays which will be ending at this particular point from this particular left. So which is going to be only 6 subarray, and then which is also going to be like 2 6. This is one more subarray, and then this is going to be one more subarray, 5 to 6. So those are the three subarrays we can build with ending as the 6 as our element. So which is going to be 3, and then the total number of subarrays is going to be 1 plus 2, which is going to be 3, and then 3 plus 2, which is 5, 5 plus 3, which is going to be 8. So this is going to be my answer. So that's how we are going to build the answer. So we are not doing anything much. We are just taking the left and then right pointer, and then whenever we meet this particular condition where the product is going to be greater than or equal to this particular k, then we are trying to reduce the sliding window so that we can have the elements whose product is going to be always less than k. So that is how we are going to calculate the answer. So let us go through the code so that we can understand better. So if we go through the code, we are going to take the answer is going to be initially 0. Suppose let's say we have k equal to 0, that means we do not want any product, that means we do not have any product which will have k as our answer. Why? Because we will not have any nums equal to 0, so we will not be getting any product equal to 0. So that's why we are going to return as 0. And then now we are going to consider two pointers, which is left pointer and then right pointer. And then now we are going to initialize the product as 1 for initialization, and then we are going to take the right, and then let's say we'll do the operation. Now for this, right should always be less than nums I, less than nums dot size. And then now I am going to multiply at each step, I am going to multiply the product with nums of right. And then let's say suppose the product is always the product is greater than or equal to k, that means the product is more than what we really want, which is k. So that's why I am trying to reduce the left so that we can match the sliding window, and then we can have the product which is less than k. Till it becomes less than k, this while loop is going to do the division with this particular nums of left. And then after doing the division with the nums of left, then we are going to increment the left pointer. And then now let's say we have left and then right. Now we need all the subarrays which we can build by considering the right as our end, and then left can the starting pointer can be from left to till right. So it is going to be right minus left plus 1. These are going to be my different subarrays which we can build, which ends at right, and then which can start from left and then it will end at right. So and then at each time we are going to increment the right so that we will move to the next iteration. So after doing everything, we are going to return the answer which we got. So if we come to the time and space complexity, let us see for the time complexity. We are going to do one loop, so it is going to be big O of n, and then maybe we'll be moving the left till the till the end of the array, so it is going to be big O of n, big O of 2n. So which is going to be like approximately big O of n itself. And then now if we come to the space complexity, here we are not taking any extra space, we are just taking only the variables, so which is going to be big O of 1 space complexity itself. So that's all for this video. Thanks for watching the video.